Problem statement is given here and the position of the given solid, a hexagonal prism, with respect to the vertical plane and the horizontal plane is shown here. As per the problem statement, the solid is resting on VP with one of its base edges. At the same time, the axis is inclined at 30 degrees to the vertical plane and parallel to the horizontal plane. So this is the position as per the problem statement. And our aim is to draw the projections, meaning to obtain the front view and the top view corresponding to this position. We know a hexagonal prism has 12 corner points. The corner points on the front are named as A, B, C, D, E, F. On the rear side, we have 6 more corner points G, H, I, L. There are only 4 corner points. Where are the remaining 2? J, K. So J, K are invisible. So right now, you may not be able to clearly visualize where this point J and K are present. So totally there are 12 corner points, and if you draw the edges, 6 edges on this hexagon and 1, 2, 3, 4 long edges or the edges of the vertical faces. So there must be 6 long edges. We are able to see here only 4. Similarly on the rear side 1, 2, 3. So only these 3 edges are shown. What about the remaining? Of course, they are invisible and represented in dotted lines. So point J corresponds to this point and K corresponds to this point. So why we define or we denote these things as dotted lines? Because if an observer stands in front of the vertical plane and look to draw the front view, the long edge EK and the long edge DJ are invisible. They are hidden by the solid on the front portion. Similarly, the edge IJ and the edge JK and the edge KL are all invisible because they are on the other side of the solid when the observer is looking from the front. So what is our aim? To draw the front view and the top view. It is difficult to imagine and draw the front view corresponding to this position. We cannot draw the front view directly therefore. But when you look from the top view is a rectangle. The length of the rectangle is equal to 65 mm, which is nothing but the length of the solid. But what is the width of the rectangle? The data is not given. Therefore, the inference is neither the front view nor the top view can be drawn from the data given in the problem statement. We assume, hence, the solid hexagonal prism is initially resting with its base on the vertical plane rather than resting on one of its base edges. So what is the advantage of assuming or imagining like this initially? Corresponding to this assumed position, the axis of the solid is perpendicular to VP, but original condition is inclined at 30 degrees to the VP. So it is perpendicular to VP and parallel to HP, and in this condition the front view is a hexagon. So from the given data we can draw the hexagon, and when you look from the top, the plan is a rectangle. The length of the rectangle is equal to 65 mm, it is given, but what is the width of the rectangle? It is not given, but we can easily project the width from the front view. Therefore, for the assumed position, we can draw the front view and also the top view. Now, if you compare the top views of the given position and the assumed position, you will notice their geometry and the size or the dimensions are the same, and the difference is their orientation. Here the top view is inclined at an angle 30 degrees to the vertical plane, but in the assumed position it is perpendicular to the vertical plane. Therefore, in order to draw the final top view, we assume the solid is initially resting on VP with its base on it, and obtain the front view, obtain the corresponding top view, and then reorient the top view to this angle, and this will be the final top view. So once this final top view is obtained, how to obtain the required front view or the final front view? So we need to follow the mechanical procedure, the projection method. What is that? We will discuss. Before that, look at the hexagon in the front view in the assumed position. We can draw the hexagon in the other way too. So what is that other way? We can draw the hexagon like this and also like this. So the second method is followed, or second orientation is followed. Why not this first one? Because in the problem statement it is given the solid is resting on VP with one of its base edges. Therefore, we draw like this. After obtaining the corresponding front view and the top view, we are going to change the position of the solid to this one. So when you tilt or change the position of the solid, only the edge JK will touch the vertical plane. All other edges or at a distance from the vertical plane. So that meets the given condition. Suppose if you position the solid like this, that means in the position in the method 1 or this one, after tilting, the solid will rest on one of its base corner rather than base edge. Therefore, this method is, or this way of drawing the hexagon in the front view for the assumed position is wrong. So don't use this. Follow this. Now we assume the solid initially is resting on VP with its base on it and the axis parallel to the HP. Corresponding to this assumed position, we need to draw the front view. So the front view is a hexagon. To construct the hexagon, draw a circle of radius equal to the side of the hexagon. And since we need to draw hexagon in such a way that two vertical edges are perpendicular to the XY line, draw a vertical line through the center of the circle and take 30 millimeters in your compass. Fix the intersection of the circle and the vertical line at the top as center and cut an arc on the circle and join those 2 points. Similarly, cut an arc on the other side, join those 2 points. Similarly, with the base point as center, cut an arc on the circle and join those points. Similarly, draw an arc on the other side of the circle, join those points. Now join these 2 vertical lines. So the construction of hexagon is completed. So all these lines are thin because this is an assumed front view, not the one corresponding to the given position. So the size or the dimension is given as 30 millimeters, that is shown in the drawing sheet. Now we need to name the points. So the points are A dash, B dash, C dash, D dash, E dash, F dash. The convention is to denote with an apostille in the front view. So A, B, C, D, E, F are here. And what about the points G, H, I, J, K, L? So they are represented within brackets because the hexagon A, B, C, D, E, F is nearer to the eye of the observer, and the hexagon G, H, I, J, K, L is away from the observer's eye and which is directly behind the front hexagon A, B, C, D, E, F. Since it is directly behind, it coincides. That means the points G, H, I, J, K, L coincides with the points A, B, C, D, E, F, and hence the rear hexagon is represented within brackets. Obtain the corresponding top view now. So what is the top view? It is nothing but a rectangle. Project the front view. So from each and every corner points in the front view, projectors are drawn. And here the hexagon GHIJKL is resting on the vertical plane. Its corresponding top view will appear as a straight line on the XY line. That means the line of intersection of the vertical plane and the horizontal plane. Therefore, on the XY line, draw a horizontal line, so shown in red color to differentiate, but it is very thin. So this horizontal red color line on the XY represents the top view corresponding to the hexagon GHIJKL. So what about this top view of hexagon ABCDEF? So that will appear as a straight line, this one. So we need to draw this straight line here. So draw that one at a distance of 65 millimeters, because the length of the hexagonal prism is given as 65 millimeters. So the top view is completed. We need to name. So first name the front hexagon, front corner points A, B, C, D, E, F. So small letters A, B, C, D, E, F. A, E, F. So they are at the top, or when you look from the top, they are nearer to the observer's eye, and hence A, E and F are shown here. And the points B, C, D directly lies below the points A, F and E respectively. So since they are directly below AEF, they coincides with the location of the points AFE. Therefore, they are put within brackets. So B, C, D are put within brackets. Similarly, the rear hexagon GHIJKL are shown here. So the top view is completed corresponding to the assumed position. So the front view and top view corresponding to the assumed position is drawn. Now the given orientation is like this. That means the axis of the solid is at 30 degrees to the vertical plane. Therefore, we need to tilt the obtained top view to 30 degrees. When we do so, only the invisible edge JK touches the vertical plane, and that line JK or the edge JK is touching VP. At the same time, it is perpendicular to the horizontal plane. Therefore, the top view of the line JK appears as a point here. So that appears as a point. So that point is here. So we already obtained that one. It is here. So now we need to reorient this rectangle like this. So for that, what we need to do is fix on XY line point KJ, at any convenient position, and through that point draw a 60-degree line. So this is point JK. Through that point we have drawn a 60-degree line. Why 60-degree line? Because the axis is inclined at 30 degrees to the VP. So when the axis is 30 degrees, obviously by simple mathematics, this edge is equal to 60 degrees. Therefore, it is 60 degrees. And we know this point is JK. So point JK is on the XY line. JK is an edge, so which is perpendicular to HP and touching VP. Therefore, it appears as a point. So JK is this, and the other end of this side of the rectangle is GH. So G1, H1 is shown here. So the distance between K1 and G1 is equal to the distance between KG. So the distance is same. Then why we are using K1, J1, H1, G1? Suffix 1 is used to differentiate or distinguish between the required front view and the required top view and the assumed top view. So this is the assumed top view, this is the required top view. So we have drawn, or we have reoriented this edge. Now we are going to draw the long edge, one of the long edge KE. So that edge is inclined at an angle 30 degrees. So or from JK draw a 90-degree line to the 60-degree line and obtain point E1 D1 on that 30-degree line. So the distance between K1 and E1 is equal to 65. So this 65. So this 65 is transferred. After obtaining E1 and D1, try to obtain point AB. So for that, again draw a 60-degree line from point E1, or draw a line parallel to this one and obtain the point A1 B1. So the length of this line is equal to EA. So this is the length. So this length is transferred. Now we can join, or before joining the other edge, we need to obtain the point LI. So LI is somewhere here. For that, measure the distance KL. Measure the distance KL. So that measurement is shown in red color, and transfer that measurement over here. So from K, you transfer the distance K to L, and that point is L1 I1. Now from L1 I1, draw a 30-degree line. So that point is C1 F1. Now we can join G1 and A1. Now we have reoriented the top view at 30 degrees. Since this is the top view corresponding to the position given in the problem, we have drawn it using thick lines or dark lines. So this A1, B1, C1, D1, E1, F1 are the corner points corresponding to the front hexagon, and these points corresponding to the rear hexagon. And notice A1, G1 is one of the long edges, B1, H1 is another long edge, or one of the edge of a vertical face or the rectangular face. Since B1 H1 is directly below A1 B1, it coincides with. Now we need to obtain the required front view above XY line. How to do that? To obtain the final front view, draw projectors from each and every corner points in the top view. Remember, there are 12 corner points in the top view, but we have shown only 6 corner points because the remaining 6 coincides with the same location. So from these 3 corner points, draw projectors. Similarly, from these 3 corner points, that means G, L, K, draw projectors. Now from the assumed front view, draw horizontal projectors from each and every corner point. So from A we have drawn B, C, D, E, F. Now we need to name the different points on the front view. So A, B, C, D, E, F, we are going to denote that as A1 dash, B1 dash, C1 dash, D1 dash, E1 dash, and F1 dash. So how this point F1 dash is obtained? So this is point F1. From F1, follow this vertical or draw a vertical, and F dash is here. So from F dash, draw a horizontal. The vertical and the horizontal intersect at the location F1 dash. Similarly, how to locate A1 dash? So from A1, draw a vertical or follow this vertical already drawn. And A dash is here, this point. So from A dash, draw a horizontal, and that intersection is A1 dash. Similarly, the other points are obtained. Now, what about these points G, H, I, J, K, L? On a similar way, we can mark G1 dash, H1 dash, I1 dash, J1 dash, K1 dash, L1 dash. So out of these 6 rear hexagon points, J1 dash, K1 dash are put within bracket. Because when the observer stands in front of VP and looks in this direction, the 6 points A, B, C, D, E, F is visible to him because those points are nearer to the observer's eye. Similarly, I, H, G and L are visible, but J, K are on the other side of the solid. So those points are hidden by the solid. Therefore, they must be put within bracket. So what is our next aim? After obtaining all these points, we need to join in proper sequence to get the required front view. So what is that proper sequence? The sequence is, we need to join A1 dash with B1 dash, B1 dash with C1 dash, C1 dash with the D1 dash, and then E1 dash, F1 dash, and finally back to A1 dash. So that is what's shown here. So the front hexagon is completed. What about the rear hexagon? Remember, in rear hexagon, point JK are invisible. So follow the sequence or join the points in proper order like this. I1 dash, J1 dash, dotted line. This is also dotted line. This is also dotted line because those edges are invisible. So in the drawing sheet, one needs to imagine the invisible edges and draw. One crude method or rough idea which may not work always is, consider the points between which you need to draw the line. So I1 dash, J1 dash. J1 dash is invisible. So whenever you encounter an invisible point, draw a dotted line. J1 dash, K1 dash, both are invisible, dotted line. K1 dash is invisible, L1 dash is visible, dotted line. Here G1 dash, L1 dash, both are visible, continuous line. Similarly, G1 dash, H1 dash, both are visible, therefore continuous line. So the point is, when you draw a line connecting 2 points, if any one of the point or both the points are invisible, then use discontinuous or dotted line. The final step is to draw the long edges or the edges of the rectangular faces in the hexagonal prism. So what are the long edges we have? The first one is A and G. So AG is one long edge. In the final front view, this A is represented as A1 dash. G is represented as G1 dash. So we need to draw a line connecting A1 dash and G1 dash. Before that, we need to decide whether it is a continuous line or a discontinuous line. So follow that procedure. A1 dash visible, G1 dash visible, therefore continuous line. What is the next long edge? BH. So BH is the long edge. So B1 dash, H1 dash. So B1 dash is visible, H1 dash is visible, therefore continuous line, thick line. Next one is CI. So C1 dash, I1 dash, both are visible, thick continuous line. The next one is D and J. So D1 dash, J1 dash. So D1 dash is visible, whereas J1 dash is invisible. So out of the 2 points, one is invisible and hence use dotted line. So from D1 dash to G1 dash, so G1 dash is here. Draw a dotted line. So the dotted line goes, and after B1 dash, already there is a continuous line connecting B1 dash and H1 dash. Therefore, we may not be able to see a dotted line between B1 dash and J1 dash. It is appearing as a continuous line, but the dotted line is overlapped here. The next one is EK. So E1 dash, K1 dash. So K1 dash is invisible, therefore dotted line. This is a dotted line. Between A1 dash and K1 dash, the dotted line overlaps or coincides with the continuous line A1 dash and G1 dash. And finally, FL. So F1 dash, L1 dash, both are visible, hence a continuous line. So this is the final front view. So in your drawing sheet, you need to draw this, reorient the top view like this, and obtain the final front view. Of course, we need to give all the dimensions, name all the corner points, give the specified angles. Thank you.